Welcome back to the Space Miata channel. Well, it's been a little bit with the head. We had to go find a new one, so now that we've got that all cleaned up and sent off to the machine shop, it's back. I need to get it sandblasted and put new valve springs and valve seals in. Put everything back together, get it back in the car, crank it over again. Remove the bad oil restrictor to the top of the head. Now that it's cleaned out and ready to go, we're ready to put that all back together. But I figured, might as well show what else is going on instead of leaving you guys hanging. This is what I do on my time after work at my main job. This is my side hustle. So let's come along and see what I do.
That's what it's supposed to look like. That's what it doesn't look like. So the thought here is split it down the middle right there, clean it up right here, see if we can bend this back in, and with that coming out we'll be able to clean this up. There is a weld right here that was keeping it in place, but since it's broke out we don't have to worry about that. On this side we have a complete solid weld, so we're going to try to just barely clean that off and take it off. But first thing we have to do is completely remove this, remove the surface welds, and hopefully there isn't any bottom welds underneath holding it in place. We'll have to go back and go get the jack to pick this up and get it high enough to work underneath to do all the full welds, as well as remaking this piece that is completely just bent. There's no way that I'm gonna work my time in trying to rebend this back straight. So we'll recut that, we'll remake a new one. I don't know as far as if this shaft is even usable. We'll try to keep it in place. It may just be a solid more roller. All right, at this point we're going to do the video overlaps. All right, so the shaft is still good. It still slides up and down. That is way too mangled for us to use. Also, it's nice and clean up. We did a little bit of washout. We're ready to go ahead and take this to the shop. We'll go make up a C-channel and a piece, and we'll remake this tab here for this to put on. We'll put all that together. Also, while we're here, I figured I'd share how I keep my regulators. These are from Harbor Freight, one of those Pelican cases. I have quick releases on the ends of them. That way they're easier to get to. But this is the best way, I would say, to keep your regulators. Since they're really big, or they're the heavy duty ones, I'm not spending another dime on putting these away again. So yeah, they're really great to have one of these. Also, I figured while we're here, clamps in this area, welding helmet. I got my level rod, that way I can do my laser level. I got my angles and my squares and my depth gauges and manual, I love this, manual micrometer, wire, tapes, all that other stuff, some extra spare cut-off wheels, some of the clamps, wrenches and all the other stuff, welding rods, some extra welding replacement, bronze, brass tips, auction, whatever, any other welding stuff you need, the replacement. There are drill bits, locks, and other odds and ends, nit bits, some electrical components. Also there's Sharpies and all the other substones and everything in there. Some replacement stuff for like wires and super glue, tape, scissors, matches to light stuff, lighter in case you need it, and razor blades, all your different kinds of bits, accessories, lines, and then we'll have on the top our space for our cutting torches. And then as we go deep down in here, it's just kind of all different kinds of boxes of other things. I try to keep everything in a box. Got my rags in here as well too. 100-yard or 500 foot tape measure. Underneath here there's all the paints and bolts and other things as well. That's not the only bin. There's multiple bins underneath here. Other different connections and leads. And inside the cab, there's multiple other connections and leads. How'd that get down there? So usually my levels will stay up in this area. That way when I get out on the job site, you know, all my main consumable stuff that I'm gonna end up getting into is in here, along with this slide out rail here with a nice 40-inch rail drawer that I need to replace the rails on because they're failing. I found these in here, so I figured that's time. Then this were also some of the reels for the electrical reels get stored in. Once I end up designing a reel rack or something to put the reels here, that's where they'll go next. So they'll swing out like a Hoosier arm. Other bucket of random metals. Keep this. I would say if you're a welder, you need to have random pieces of metal to be able to do different jobs on the fly. And then I have our different oxygen. So we have 2 oxygen bottles with 1 acetylene bottle. I figured that's the ratio I'd run through and about, working. And then you have my argon bottle for TIG welding and all the other specialty weldings that I need to do. Hammer and chain storament and some oil for the welder in case we need it, or you need to heat treat something. And then there's our little piece we're gonna store underneath here. D-rings for tie down. I might do a 2-inch square tubing come down here and stick out for something later, but I'm not too sure. I do want to add maybe like another slide rail underneath here for another tool storage, but since the straps go here, useless if you would be able to try to get into it. So maybe something underneath here. We'll redo the toolbox at one point, maybe bring it lower so it's not so high. But having it that high also allows for you to get in there to turn your T-handles up underneath and get in there and turn those T-handles that you need to be able to. So that's one thing. As well as little ratchet straps to hold down the bottles once we get these. A little loose, but they still hold pretty well. Now that I'm at the shop, I went ahead and took a picture of that tab. And now we'll go ahead, minimize this out. When we'll upload it here, we went into create a new canvas, then we went to insert, remove this. We did insert, we did insert on canvas. We inserted the picture that was finished. And then once we got done with that, we're gonna scale it to size via the diameter of what this pin size is. So we will see that here in a second. Now that I've calibrated it to size, we can start a new drawing, fresh surface, and then we'll just trace out our hole. And we're gonna know that's a 1.50 inch hole. And we're gonna move it so it fits directly. Sorry, doing this on a laptop, it can be a little slow. Fit directly, come on. Right there, over that hole. Then we're gonna sketch out the rest of it. And we probably wanna start over here. There we go. And then continue our sketch all the way out. I've got it drawn out. I'm gonna go ahead and extrude it. And I wanna extrude, on focus, this. There we go. Simple as that. And we're gonna say that is 1/2 inch material extrusion. There we go. Extruded. We're gonna take that into design, go to manufacturing. We'll take it into fabrication. We're gonna do cutting. Click on that. We're gonna go over here, sorry, to our tool. We're gonna select our tool. Selection. And we're gonna do library of tools. Hopefully there'll be one already pre-saved. No, okay. We're gonna go up here at the top plus button. New tool. We are gonna have all those different tools. We just want the plasma cutter. There we go. There we go. It'll have a description, arc droid. Okay. And save that. And then right down here, accept it. Bingo. There's our arc droid. Nozzle diameter, kerf width. Yeah, that's all about close enough to make it work. There we go. We're gonna choose our geometry, which is our face. Here, and heights, passes, oh, we don't need, okay. Passes, we wanna do smoothing. That way everything else doesn't, it gets rid of all the extra G codes. It doesn't have a whole bunch of points. And then we make sure, yep, 60-degree sweep angle. Make sure that all your post-process comes out good. Now, one other thing too. If you're doing something and you're having a hard time trying to get those damn cuts to be somewhere really fine and in between, like really fancy cuts, change your lead-in sweep angle and your lead-in distance. Change these a little bit, and you'll get a better cut on much finer lines and like words and stuff. So now that we got our little check process, everything turned out well. We're gonna open our post processor. We're gonna name it wheel dumpster tab. Then we're gonna go into our post process. We're gonna choose from library. In order to get this, depending on what machine you have, I have to go to ArcDroid's website and write it in here. And then there's a link down below. I'll post in Fusion 360 post processor. So you'll download that, you'll get it to your computer, then you'll come into here, you'll open the file, you'll come up here to your local, then you'll come up here to this top one, import. We'll go to find our downloads. You'll find it right there where it's labeled either for your machine or for the one that we're doing right now. We'll use that. That gets uploaded. We're gonna select it. That gets loaded in, all the programs and all the settings look good. Pierce height, stop delay, G feed. Now some of these you might want to change if you're more advanced than I am, but for the most part I'm just making sure they look good as what the other ones were saying. Post that, done, and I've already saved it to my thumb drive, so let's take this over to the machine. We are here. So now we go ahead and set the parameters. Clear Z is the thickness of the material. Pierce Z is how high the tip needs to be from the material when piercing it. Cut Z is the actual cut height of the torch when it recedes back up. Kerf is the width of the cut thickness. Pierce delay is how long it's going to take for it to pierce through before it starts moving. And off delay, you want to have a little bit of this for the tip cooldown. Let's add a whole second because that's going to be nice for that tip. And then we want to add load in, clear whatever we're working on, load our G code. There it is. Beautiful. Oh, also going to need to go back into trace, functions, and we're going to go input. We want this origin of input to be, we're not wasting the most amount of material. Oops. We want outside cut. That way, see here, origin. See if I can flip. There we go. I want it so it doesn't take up so much material. There we go. We want it in this shape. That way it's not taking up so much material. Save it. Check. Exit. Now, let's go ahead and make sure we want to clean our material. We're going to zero it out. We're going to run it without having the plasma running. Nope. See that touch and the damn tip to the top. What happened here? There we go. It saves some other parameter. So go back in here. Let's change the parameters that I had liked earlier when I was doing some cuts last week. There we go. That's a lot better. Make sure that the arm doesn't get blocked or anything in the way, or it's actually gonna make the full cut. Oh, what happened here? See? Sometimes it's best to run the machine to make sure. Let's try that again. Because I do not need just a whole cut tonight. What is going on here? Oh, let it work, please. I'm not a really smart person at this stuff, but... Well, this is no fun. So, I'm hitting my max Z height because it is at the lowest setting. So I need to reset the torch at the new height. That way I have a lot more probing depth. So, quick transition. Just did some basic cardboard templates. Fits that. Cut it out with the plasma. Mag drilled it first on the plate first before I did it, and then scarred it. I was a little excited. Mag drilled it. Then I traced it out, plasmaed it. I cleaned out and grinded everything out, beat it out of the plate. We're gonna replace this one. We got to cut it straight down and then wash out the weld underneath, as you saw in the video. So we're just gonna take this.
Just getting back to the job site. I have an O-Light clip
back together.
and Lux Pro light pucks from Home Depot or Lowe's. They're these little stick-on ones, and use a little regular battery that you use for your welding helmet.
Clean it up a little bit.
So I use these before I have to fire up the generator. There's my main Craftsman drop light.
I could clamp it, but
use that.
It is
pretty frequently. I need to get a standing one, that way I don't have to move it around to do a lot of these cuts and shine the light where I need to be. So we're just cleaning up the C channel, getting it ready. We're gonna go ahead and cut it down to length, and we're gonna come back to the container here in a minute. We're gonna clean it up a bit more. There's still, from all that torching, as nice, as clean as it can be, I like to be able to lay a nice smooth bead in there. So we're gonna clean it all up, get it nice and straight, make sure that our fitment is good and that C channel fits in there. That's why we're cleaning up this other wall. Make sure that that's actually square. I couldn't really get a square in there with some bent material. So the cut wasn't completely straight. It happens. Come in and grind it. There's some metal that's all bent out of shape. It's going to take some grinding and some bending. So you're going to use this car jack here, lift it up, put pressure on the low side, and we're going to end up beating some of these high sides back down. That'll bring it in level. So just keep on working that. Bend some pieces back with the actual weight of the, that way I'm not having to hit it. And some parts I need to bend flat, so that's what the hammer comes out for. Not all the material you want to heat. It'll create stress on the material if you're not able to cool it slowly. So I prefer to use the hammer and give her some love taps, get her back straight. So probably someone in the comments will say that's not the best way to do it, but that's the way I do it, and it's the way my customers want it done. So it's all customers always right. You got to do it the way they want it done, and if you can find a better way of doing it, please suggest that to them. Don't always. Not every customer, I'm going to say, is exactly right, which they do have great ideas, but there's sometimes when it comes to when you work in there all day and they're just there for a brief moment. It's better to go with the sense of judgment that's safe, and if you have to deny a job due to safety concerns, I would highly suggest getting away from it. Being sued and going through the whole lawsuit of all that is not fun. I haven't personally experienced it. I know of people that have, and it's not worth it. So just be safe out there with that. So here we're just getting, let's see, ground clamped up, getting our leads and our temperature set right. I like to do 60-11 passes and 70-18 caps, especially for a lot of these pieces that get used and pulled on a lot. So we're getting here, getting set up. I put the little clip light on my side. Don't really actually think that helped. Don't think I'll do that again. Maybe if I had an auto lens that might work, but I use a solid lens in the field, so I don't have to worry about batteries. I do have a Speed Glass M3. I really love it, but to keep it away from stick welding, I just keep it at the house and do a lot of TIG and MIG with that. So here I'm getting that C channel in there. I got to beat that flange flat, getting the square out, making sure it's nice and straight. I'm gonna burn a few tacks in. We're gonna come in from the sides, underneath, get all that C channel set, and then go them rods in. So for instance, that plate that was on top, I was using 6011 to weld that together, being that it's not going to end up receiving a lot of pull on the plate, but the ends of the C-channel and where that gusset and all those other plates meet up, definitely going to run some 7018 in there just to make sure. 7018 is a much more flexible weld, less likely to crack. 6011s are great for good penetration. If you're just trying to if you're just trying to cap something, it's going to receive a lot of torsion and twisting. 7018 is your best friend. Stacking those on top of each other, trying to expand a gap, not too bad of an idea. 6011s are definitely my favorite for getting those thick pieces of metal together, or burning two pieces that need to be a nice solid fuse when I grind it later. It has plenty of penetration and no porosity in there. 718, you can get a really nice penetration with it, but you have to risk burning through, as well as just being super hot for how the rod is naturally. It burns much hotter, and if I say it's another 20 amps more hotter, which is substantially a lot. So 20 to 50 depends on what kind of rod you're running, all that. Love 718 is a lot smoother. So here we're just getting the wheel put into place, making sure that shaft and everything's going to roll right. Take a look at the other side, make sure it looks the same. I don't want to make one side look different than the other. We really need these things to be pretty close. We're not building rocket ships, but we want to be really close to getting that thing loaded up every time, so that way it's safe and it's not going to fall off the container, fall off the truck. So here we're just putting in the last little beads of burning them in, and then we'll switch over to some 7018. Chip off slag. There we go. Some 718 on top of that. Keep it all crispy and clean. Get it all together. And side welds. There's a cap there. There was some really thin metal, so I decided to just replace it with some 1/4 inch that I had on hand that didn't have any, looked like about 1/8 inch stuff. So 1/4 wouldn't hurt anything to go a little bit thicker. That's what I had on hand. It's cheap, it was free from the last few jobs, so didn't have to charge the customer any extra for that, unless there's a bigger piece, like that whole entire cutout for that shaft to go through on that one side. That's a charge for that. I'm not gonna include that in labor time. That's a piece of material that came off from a sheet of plate. Even though it was from another job, it still gets charged to the customer for your time, labor, and putting it all together. That gusset, though, that I was able to cut and save, I don't charge the customer for any of those replacement works besides the hour and labor time that it takes to put that in there. Also, too, if you're using consumables, grinding wheels, cut-off wheels, you gotta use welding rods, anything else you can think of that you're gonna actually have to use and burn up and you won't have afterwards. Definitely charge the customer for that, and it's not like a high price. You're not gonna get $6 a welding rod. You need to figure out what your price range is, and everybody's different, and every state is different, every country is different. So figure out how much that was that you use from the pack. Add your percentage increase of your choosing, and then that way you're not completely losing and trying to make your hours cover for your consumable materials. It's all in business practice too. That's just how I run mine. So if you guys wrap it into your shop hours, then that's up to you guys. So here, just putting the last 718s on everything, get it all clean, chip off that slag, and we'll pretty much just about call this a day. I think we're about done here. I don't remember the rest of this video. It's been a few weeks since running it. And cleanup process, get that wire wheel on it, get all those beads looking clean. We're gonna paint this. The customer did have his dumpsters painted. We don't want to leave the customer hanging without leaving it rusty. So get all these tools out of the way, get everything ready. We'll just lay some basic Rust-Oleum paint. No sense in laying primer down. So let's see here, we can get everything all set up and then reel up. Usually one coat will do if you lay it not super thick. These are just dumpsters. This is going to be a part that gets hit a lot. So one nice good coat will do. All right, all done. So that was a fair amount of work getting it all cut and welded. It's not the prettiest of welds, but we're also just trying to get this done for the customer in the morning. That way they can get out to their other jobs and do all the other service work. So that's that. If you're doing a lot of this work late at night, I would highly suggest in these toolbox lights. I found them at Lowe's and Home Depot. I'll put the link down in below. They are so awesome. I don't know if you can tell how much light they produce, but for a low light ambient area now, I'm able to work and be able to get all my stuff rolled up without having to have the welder on. This O-light clip though this thing's amazing. That's high, see low, high. Well, thank you all for watching. I know it took a little while to make this video, but I was trying to figure out what to do with the Miata, and nothing else was coming up for anything because funds were a little low. So work has been going really good, so I figured I'd share some of that. I'm not making any money off of YouTube, so if you guys would like and subscribe and comment down below, that would help out a lot. Maybe I can grow this channel. We'll see what happens. Until next time.